time. I know everybody is tired, and I will make sure that after this lecture you will be extremely tired. So, I want to talk about a pattern, or like it's a practice, or something that I kind of like, I have zero validation about it. It's something that I figured out. Tagged unions and factory pattern, like this is the title of the lecture. So, I'm Guy, team lead at Matia. This weekend I'm turning 31, husband, the father to a little junior, 7 years of React, suffering, and I really like building stuff, okay? So, tagged unions and factory components. I don't really know how to kick it, like how to start it, so I want to go by examples. But first, let's understand what is the problem we're trying to solve. Have you ever built a component that tries to do like everything? So let's start with an example, a classic chat bubble in a chat application. So we have some chat bubble, author name, which is me, some timestamp, and text. We'll dive into the implementation in a moment, but seemingly innocent, right? Like small component, like, okay. Now let's look inside how it's designed. So at first glance, we can already see some problems. This component is trying to do a lot of stuff that can lead to like undefined or undesigned behavior. We have a set of props here. All of them are optional, all of them conflicting, because we want to render only one like kind of chat bubble, either it's text or voice. We don't want to mix them together. So we want a text, voice, GIF, video, whatever. And the implementation looks even worse. We start conditionally rendering all of those stuff. If we want to render a text, we pass the text prop. If we want to render like an audio play, we pass the voice URL prop and as such. And we have too many optional props. We have conditional checks in our JSX. And we can have multiple rendering scenarios. Now, what does it mean? It means that impossible states are allowed. For example, I can pass text and voice URL. No one will stop me. What will be rendered, I don't know. Not something we want. The same here. Okay, let's try to improve it. Maybe we should add like a message type prop that guarantees that we render only one thing. So now we add this, another check, okay, which makes it even worse, but it is slightly better in terms of like design. But still, we can still produce impossible states. We can say message type is text, but we provide voice URL and GIF URL, and what will be rendered based on the implementation, nothing. So TypeScript doesn't really know how to connect a message type to whatever props are passed, and we're not talking about like the runtime, we're talking about us writing code. We can make mistakes. So TypeScript is blind in this situation. So how can we improve it? What can we do to make it better? And this is where tagged unions come into play. I'll explain simply by example. So let's focus on this set of props. We have message type, we have all of the rest of the like conflicting props, I would say. And the first thing I'm gonna do is create a new prop which is called message to simplify our life, and I will wrap all of the other props inside. The next thing I'm gonna do is take the message type and put it inside a simply type, okay, to make life easier. So far nothing changed, we're still at the same level of problem, but now what I'm gonna do is start breaking this whole mess into smaller pieces. And the first thing I'm going to do is I'm going to extract the image URL variant, as if like it's a special case, to an interface. So I'm going to grab the type of image and image URL and put it in an interface. I'm going to do the same thing for video, GIF, voice, and text. And now what we're left with is a single prop that can take multiple shapes, but they do not conflict, like actually they do conflict with each other, they cannot coexist. So the way it works is by having this union, the type that can be passed to message can be only either one of those stuff and not like any combination of them. And the pattern we use, the tagged unions or discriminated unions, is basically having one common property among all of the interfaces. I chose type, and the value is a string literal for each variant, which will be used to narrow down the type of message to that exact interface that we want. Demo time. So this is like a chat bubble I made, the component. We have type here. Opa. We have type here, which can be, because it is the only shared property among all of the interfaces, we see it like as a union of all of them. But the message itself is the union of all the interfaces, and what we get is when we assert if type is text, the message got narrowed down only to the text message variant. So if I try to access some properties here, we only have text and type. The rest of the properties do not exist here. So the cool part is that even if I pass something by mistake, for example, image, now we get a type error, okay? Just a second, here. This is like an error, type text does not exist on image message. And if we remove it, just a second, here, we have image URL or type, and it scales, and it's good, because now we moved the runtime checks into a compile time check. So we no longer need to check it like in the JSX, we can check it like when we write the code. So this is the pattern. Now let's look, like how does it actually work internally. So we need to go back to some basics. We need to understand type narrowing. Type narrowing is basically the capability of TypeScript to take a type which can take multiple shapes and narrow it down to like the smaller types that make it, okay? I know it doesn't make sense now, but let's look at the example. So value here is either a string or a number. When we do type of value equals string assertion, we basically tell TypeScript, I want this condition to narrow down the type from being either string or anything to just string. So when we do return value here, it is typed as string only, like the number variation does not exist here. And since we're returning here, the other branch in our control flow has only number as the type because we already handle string. So this is type narrowing. Type narrowing in tagged unions is basically the same thing. Just like I explained earlier, instead of having like primitive types, we can have objects, and each like variant in the object should have only one shared property, which is in this case type. So we have type data, type error, type loading, and each variant has its own set of properties around it. So data has the data property, error has the error property, and sorry. So when we try to get the result value as a string, we get a result type, which can be any of those things. And then when we start asserting, if type is data, we return result.data, and now result is only the narrowed version. And because we returned, type here got narrowed down to only error or loading. And lastly, we're left only with the error type. And because we're doing a very simple check, like a string check, and not some complex stuff, we can use a switch case statement. And based on each case, for the discriminated value, which is type here, we can return whatever we want with the narrowed down version. Cool, it works, nice. I guaranteed another part in the lecture, factory pattern, what does it mean? So, I have this little thing here, okay. I will drink water, sorry. So far, we learned about discriminated unions. The implementation didn't change. Actually, it's really the same code. In terms of TypeScript, nothing here changed. But since we assert each case, we can eliminate unnecessary checks. So let me go back. Because if we're in message type text, we know text necessarily exists. The same follows for the rest. So we can eliminate one check. This is slightly better, not that much. We still have all of those conditional renders. We can do way better. So first thing I'm going to do is extract this component outside, like all of this like conditional renders, into something called bubble content, which takes only one prop, message. I was lazy, so I literally took the parent component's props, use the brackets notation to like grab the message from within, and I render the same thing. So we have established that if we're checking on type, we can use the switch case. So this is exactly what I'm going to do. I'm going to switch on message.type. and for each variant, I'm going to render whatever was rendered before. And this is how we create a factory. But it's like the same thing, right? Like, what did we change? We added like unnecessary abstraction, so it maybe looks a little nicer. Like, there's not like that much of a difference. But let's be realistic. This is not how production code looks like. This is very generous in terms of like simplicity. In a real world scenario, our smaller components like either text or voice will have state. It will have much more nested like JSX. And let's focus on the video. This is not how a video player or like video component looks like in reality. It's like, okay, it's very simple, simplified version. So what we're going to do is extract the implementation, the actual implementation, into a smaller component, bubble content video, and it will take only one prop, which is the message. And the message in this context is already narrowed down. So the message prop is video message in this case. And we're going to do it for the rest, okay? So, okay, it looks good. Now we abstracted it away, but modification would be a nightmare, right? Because we have a lot of places we touched, a lot of like complexity, and it's actually quite the opposite. If this is our implementation, I don't really care about the implementation itself. I know it's isolated, I know it's contained. I have message, which is message video, just like we said, and this is the interface. Now, if I want to modify it, let's say product now requires text also to be rendered when we have a video, I can add it here. I can modify the component of bubble content video. I now also support text in such a way. And let's look at what we need to change in the factory. Nothing, basically, because everything is delegated. So every change in the underlying component, even from the top, is not reflected on this factory. So it's contained. And we can do even better than that. Because our set of possibilities is finite, we can add a default clause in the switch statement and use a cool party trick added in TypeScript 4.9, the satisfies block. And since message, like we already handled all of the cases that message can live in, we narrowed it down to basically nothing, so its type is never. So if we expect message type to be never, we get a compile time check, and we will also add a runtime check for, I don't know, whatever like situation that could happen, okay? And it's really helpful because now, when we implement or like add a new variant or forget to, like for example, we forget to handle the image case, we'll get this beautiful error here that message is of type image message and it doesn't satisfy never. Cool, that's awesome. I'll use it everywhere, right? Cool pattern, but maybe not so fast. So just like everything in life, it depends. So this pattern is perfect for multiple variants of the same concept. I don't want to be super specific here. I would say concept. Distinct UI shared behavior, which means the behavior is generally the same. We display a bubble or something, and the UI only changes. And when they like delegated components have only single responsibility. If they are like complex components that also have callbacks back or such stuff, maybe we should avoid it. And it's wrong necessarily for components that have small Boolean toggles, like is active, is disabled, such stuff. If the variants are fundamentally different, we should avoid it. And if the variants contain like different business logics, okay? You should ask yourself, are these the same thing with different representations? And if the answer is yes, probably this would be the way to go. And always remember, types are better than conditionals. Move complexity from runtime to compile time. Thank you.